No. Alright, so because logarithms are exponents, it is that inverse of an exponential. The properties of logarithms can be derived from the properties of exponents. Okay, so these properties of logarithms can be derived from the properties of exponents. So we're going to go over the product property first of logarithms. That can be derived from the product of powers property of exponents. Okay, so the logarithm of a product is the sum of the logarithms of its factors. So if I have log base 2 of 5 times 6, so I have these two numbers within these brackets, I can split that into log base 2 of 5 plus log base 2 of 6. So if they're multiplied together here, I can split that into addition and vice versa. Okay, so if I have an addition of logarithms with the same base, I can multiply those two numbers afterwards together, okay, to get log base 2 of 30. Okay, so below there is just the proof of why this works. So let b raised to the x power equal a and b to the y equals c. Then using the definition of logarithm, x is equal to log base b of a and y equals log base b of c. So I have b to the x power times b to the y power equals a times c. Okay, product of exponents here. I can add those exponents together since I have the same base. If I bring in log base b to both sides, it cancels out that b right there, and I'm left with x plus y. And then I have log base b of ac. Okay, x was equal to a. So I can split this into log base b of a plus log base b of c equals log base b of ac. So what we're going to do today is just kind of estimate or approximate. What are we doing? Can we focus, please? Yeah, we're focusing. You're not. Okay, we're going to approximate the value of different logarithms. So example 1, we're going to use, Tegan, you're taking your test. Sit down. Go away from them. Away. I know. Tegan. Alright, so we're going to use log base 4 of 3 is approximately 0.7925. Okay, and we're going to figure out log base 4 of 192. So to do that, I'm going to change this into multiplication of two numbers. So if I have log base 4 of 192, okay, I know I need a 3 involved in this. So I'm going to divide this by 3 and see what I get. Okay, so when I divide 192 by 3, it'd be 3 times 64. Okay, now 64, I don't have that approximation here. I just have 3's. However, I can't divide this by 3, but what I can do is change that to 4 to the 3rd power. Okay, so 4 times 4 times 4 is 64. Okay, so I just changed this to 4 to the 3rd power because I know I have this log base 4. Now if I have log base 4 of a 4, that's just going to cancel out and be 1 because I have a 4 and a log base 4. So that's why I changed it to that. So now that I have these separated into multiplication, okay, I can use the product property of logarithms to change this into an addition problem. Okay, so this would be considered log base 4 of 3. Okay, so I have log base 4 of 3, okay, plus log base 4 of 4 to the third power. Okay, so if you have that product or multiplication in your parentheses, we can change that to addition. Now, we were given that log base 4 of 3 is about 0.7925. Okay, so I have 0.7925 here. Now this log base 4 of 4 does just cancel out. Okay, those cancel out and you're left with this power of 3 here. So it'd be plus 3. Okay, so if I have that log base 4 of 4, cancels out, you have that 3 left over. So my approximation would be 3.7925. Because you can't enter that into your calculator. You can enter log base 10s into your calculator, but not log base 3s, 4s, stuff like that. Okay, we're going to do another example. So we're going to use log base 4 of 2 is about 0.5, okay, to approximate the value of log base 4 of 32. So that means I need this in terms of 2's. Okay, so changing log base 4 of 32. Okay, if I divide this by 2, that would be 2 times 16. Okay, and you can do this a couple different ways. So I can change this into log base 4 of 2 times 4 squared because I know I have this base 4 here and 4 squared is 16. So those will cancel out and I'd be left with 2 here. Okay, or you could do log base 4 of 2, okay, and then 16 is 2 to the 4th. Okay, so we could just do 2 times 2 times 2 times 2. Okay, so 2 to the 5th is 32. Okay, so I just have these multiple 2's here. So if I do it this way, okay, I would have log base 4 of 2 plus, since I have this multiplication in parentheses here, log base 4 of 4 squared. Okay, and again, these 4's would cancel each other out. Okay, so I have log base 4 of 2. Okay, that's 0.5. So I can plug in 0.5 instead. Okay, then plus these ones canceled, that would be 2. And I would get 2.5. Now here, I could change all of these, since these are all multiplied together, we can change that to addition. Okay, so log base 4 of 2 plus log base 4 of 2, and so on here. Okay, so since they're multiplied within these parentheses, we can change those all to addition. Okay, and we know log base 4 of 2 is 0.5. So instead of log base 4 of 2, we would have 0.5 plus 0.5 plus 0.5, and so on here. Okay, and when I add all of those together, I still do end up getting 2.5. Okay, so either way you think about that, sometimes it does help to try and get this base of 4 if you have a base of 4 so they cancel out. But if you know you can multiply all of those together anyways, okay, and then add them, you'll get that same answer. Okay, so we're just using this product property to approximate a logarithm. Okay, so I'm giving you what log base 4 of 2 is. Change the log that you're given into a log base 4 of 2 to approximate that answer. Okay, questions on the product property?
So did you cancel the log 4 to 4 there.
Yes.
And then that other 4 stayed there on the other side. So that one gets canceled too.
Where? There's no 4 over here.
No, on the left side.
Here?
You plug, no, the other one.
Oh, yes, I canceled this one out.
No. The left one. So you see log
Where's the
4.
log form?
This one?
Yeah.
I used this.
Oh, okay.
So if I had log base 4 of 2, I know what number that is. It's 0.5.
Yeah.
So I just replaced that with 0.5.
Okay. Yeah, okay.
Yeah. So you're trying to get to this from the, trying to get this from this.
Okay.
So that you can replace it with this 0.5. Okay, that's what I did up here too. So I needed a log base 4 of 3. So I divided this number by 3, so I would get a log base 4 of 3. Okay, so I could replace that with what the approximation is. Other questions? All right, then on the back, we have the quotient property. Okay, this one's similar to the product property, except now if you're subtracting, you have a fraction, okay, and vice versa. So here in this example, okay, I'll skip over the proof part. So in this example, we have log base 2 of 5 over 6. Now I can change that fraction into subtraction of 2 logarithms. So I can take log base 2 of 5 and subtract log base 2 of 6, since it's in the denominator. Okay, and vice versa. If I have this, I can change this into log base 2 of 5 over 6. Okay, so that's what we're going to do. So example 3 says the pH of a substance is defined as the concentration of hydrogen ions H plus in moles. It is given by the formula pH is equal to log base 10 of 1 over H plus. We want to find the amount of hydrogen in a liter of acid rain that has a pH of 4.2. So we're going to find this H plus value when we're given this pH is 4.2. So I'm going to plug in 4.2 for pH. So we have 4.2 is equal to log base 10 of 1 over H plus. Okay, now since I have this fraction here, I can change that fraction into subtraction of 2 logarithms. Okay, so I have 4.2 is equal to log base 10 of 1 minus log base 10 of H plus. Now, log base 10 of 1 is going to be 0. Okay, so if you have a log base something of 1, it's always going to be 0. Okay, so that's going to equal 0. And I still have this minus log base 10 of H plus. Okay, so if you have log base of any number of 1, okay, it's always going to be equal to 0. So if you see that 1 there, it will be 0. So now what I have is this 4.2 is equal to negative log base 10 of H plus. Now, before I bring in a base 10 to get rid of that logarithm, I'm going to divide by negative 1 because I don't want this negative here. Okay, so I have negative 4.2 is equal to log base 10 of H plus. Okay, now to get H plus by itself, okay, we're going to bring in that base 10 to get rid of our log base 10. Okay, and I have to do that to both sides so that it cancels out here. So I have 10 raised to the negative 4.2. That will equal that H plus or hydrogen ion. Okay, and if you enter that into your calculator, Okay, 10 raised to the negative 4.2 power. Okay, you're going to get a small decimal here. Okay, you get 0.0000063, and that's in moles of hydrogen. Okay, so we can use our quotient property here with that fraction to separate it into a subtraction problem instead of having that fraction within our logarithm. All right, so the last example I have on here is one that you would most likely see on your assignment. Okay, so I don't think I have any word problems on your assignment like the last one, but I do have problems like example 4 on there. So again, we're going to use a log base to approximate the value of another one. So here we have log base 4 of 3, again, is about 0.7925, and log base 4 of 5 is about 1.161. And we want to approximate the value of log base 4 of 5 over 3. Okay, so it's easier to approximate this value when it's not in a fraction form. So I want to change this into subtraction instead. So I could change this to log base 4 of 5, so taking the numerator, log base 4 of the numerator, minus log base 4 of the denominator, which is 3. Okay, so I'm just changing that fraction again into subtraction. Now we were given log base 4 of 5 is 1.161. So I can replace log base 4 of 5 with that number. Same thing with log base 4 of 3, where we're given that approximation here. So I can replace that with 0.7925. And then I can just subtract those two values to get my approximation of 0.3685. Okay, so if you have that fraction, we can change it into subtraction. If you have multiplication, you can change that into addition of your logarithms. Okay, questions?